Okay, welcome to Chapter 3 of our robotics class. We're going to talk about components of a robot in this video. And we'll get started by talking about different power supplies that a robot can have. The three main power supplies that are commonly used are electrical, hydraulic, and pneumatic. And all of these power sources have their pros and cons and are used for different purposes. And we're going to talk about each of them in a little bit more detail. So the focus of this class is in robotics and not, it's not an electrical class. And most students taking this class will have had either DC circuit analysis or industrial electricity. So I'm not going to spend a lot of time going over this, but this class technically has no prerequisite. So for the occasional student that may not have a background in any electrical classes, we're going to go over some very basics. So electricity is the flow of electrons through a circuit, and they are used to do work. And voltage is defined here as the potential difference between 2 points. Again, I always like to think of the analogy of water flowing through a pipe. And in that case, voltage is somewhat similar to the pressure in a water pipe. So if you can visualize that when you think of voltage, that's essentially telling you the pressure, the imbalance between the 2 points in the circuit. Amps or amperes are used to measure the quantity of electrons passing through a circuit. So if you're going with that water pipe analogy, you could think of amps as how much water is flowing through the pipe, or in this case, how many electrons are flowing through the pipe. And resistance is the opposition to flow. It is what essentially slows down or makes the flow more difficult. There are two main types of electrical power, electrical circuits, and they are DC, which stands for direct current, and AC, which stands for alternating current. So in DC, the electrons flow in one direction. So again, using that analogy, we're thinking of water flowing through a pipe. It just flows in one direction. Alternating current, the electrons flow back and forth. So there, I guess you could imagine those electrons or water in a pipe sort of sloshing back and forth, back and forth, back and forth. So in DC, because the electrons are only flowing in one direction, the polarity is very important. It's not as important in AC. So polarity essentially just means you've got a positive end and a negative end of the circuit. And the electrons flow from one point to the other. And so if you wire together a circuit or plug something into a DC circuit in the wrong orientation, if you put it in backwards, that can cause problem because the polarity in a DC circuit is very important. So how are the electrons flowing? In what direction are they going? So originally scientists believed that the electrons flowed from the positive end of a circuit to the negative side. And it turns out that's actually backwards. So technically or correctly, the electrons are flowing from the negative terminal to the positive terminal. So DC circuits are the type of circuits you would get if you wire up batteries. Batteries provide DC power, and the way that you wire together your batteries is going to affect the amp hours that you can get out of that circuit. How much power can be delivered over time. So in the example here, 10 amp hours means that you can deliver 1 amp for 10 hours, or maybe 2 amps for 5 hours. So 1 times 10 is 10, 2 times 5 is 10. So you can the total there, the product of those numbers is going to equal the amp hours. And so if you need to increase this, the amp hours, one thing you can do is to wire batteries in parallel. So what does that mean? Well, essentially you can see here in the diagram that the circuit is connecting and it two batteries, but the circuit sort of splits and the electrons would be flowing through both of these batteries simultaneously. That they are wired together in parallel. So the path splits, goes through the two individual batteries, comes back together. This increases the amp hours of a system. So it can extend the life of the batteries, allowing them to last longer, assuming the amperage is constant. Sometimes, though, you might need more force. Again, thinking of that analogy with water flowing through pipes, more pressure, the ability to do more work. And so the way that you would increase the voltage of a system is to wire batteries together in series. And here's an example of a series connection where you have two batteries connected to each other. So in this case, the path of the circuit doesn't split. It's continuous. It goes through one battery and then the next. And that is going to provide more power. Of course, you're going to be sacrificing the amp hours by doing that. So what you may need to do is a combination of both, series and parallel. So in this example here, we have 6 batteries in total. Two of them are wired together in series, another 2 in series, and another 2 in series, but those 3 pairs are wired together in parallel. So moving on to AC. AC is the type of power that we get when we plug an appliance, or in our case, a robot, into a wall outlet. This is alternating current, meaning that the flow of electrons is flowing back and forth rather than flowing in one single direction. So with AC current, you have a sine wave to indicate the flow of electrons. It starts at 0 and then increases to a maximum positive value and then decreases back down to 0, all the way down to a maximum negative value, and then back up to 0. And that is one cycle. So the voltage is constantly fluctuating. If you can imagine those electrons kind of going in one direction, slowing down, stopping, reversing direction and heading back the other way, slowing down, stopping, then reversing direction and heading back in their original direction. That's what is represented by that sine wave. With DC, the voltage is constant. The electrons are constantly flowing at the same voltage. So as I said, that cycle from 0 to positive, back to 0 to negative, back to 0, that's one cycle. And the rate at which the electrons cycle varies in different parts of the world. Here in the United States, we have 60 hertz electricity in a typical wall outlet. The root mean square, just to explain this term, is essentially what's used to average out the value of the sine wave. And essentially what that means is we are squaring the voltage, and then we are taking the square root of that voltage. Those are mathematically opposed or opposite reciprocal mathematical operations. But the reason we do that is because if you take a negative value and you square it, it becomes positive. And then when you take the square root of it, it remains positive. So it's just a way of averaging together those positive and negative values. If we didn't square it and then root it, the average would basically be 0 because the negative and positive would cancel each other out. So this is a way, a little mathematical trick to average and find the voltage, keeping everything positive. The typical outlet that you might have in your home is a single phase AC. So if we were to measure the voltage, we'd have that one single sine wave going up and down. And an alternative to that used in industrial applications is three-phase AC. So if we look at the sine wave, you can see there's a problem potentially with single phase in that periodically your voltage is going to be zero as it transitions from positive to negative. And that could be a problem. We might need a more constant voltage to keep our sensitive machine or robot operating properly. So you can have also three-phase AC where you have three phases, three cycles occurring simultaneously. So at no point in time does the voltage drop off to zero. No dead spots with three-phase AC. So again, the outlets in your home in typical residential applications or even commercial applications are 120 volt single phase AC. Um, so it's really only for industrial applications, or maybe the outlet that you plug in your dryer, your clothes dryer into might be 220 volt. Um, but it's all single phase. Three phase is we do have in our lab for some of our equipment runs on three phase, but typically what you're seeing in most situations is single phase AC power. And so, like I said, three phase is used for industrial, and that's so that the voltage it never hits that dead spot, never gets to zero. And this is probably getting into a little bit more detail here than we need to know for this particular class. All right, I think I have quite a few minutes here left. As I look at my timer, I'm only at about 12 minutes, but I'm going to stop here so that it's a stopping point that makes sense, and we'll resume talking about hydraulic power in the next video.